So in this media, we are going to discuss a very important topic, very important topic as part of your oral also and as part of your shipboard, you can say understanding of the ship, of the engine. So it is variable injection timing. There has been a constant evaluation in this technology, and there are many pretty things which are coming now. Also when we are speaking, there are many other changes that are occurring, but I have tried to make it concise. I have tried to take all the material from different sources and bring it here in under one umbrella. So variable injection timing, often referred to as VIT. So we'll just go in a jiffy and see what all we are going to discuss is conventional VIT system, super VIT, FQS, that is fuel quality system. So we are going to see in depth of all these aspects. So without any further ado, let's move on to our first slide. So when we speak about conventional VIT, so what is the objective is there that engine may be fitted with a mechanical or electronic VIT. Okay, now if the fuel quality has changed or if the fuel pumps are worn, the pmax will change. So now your pmax is going to change. Adjusting the pmax of all the cylinder is done by adjusting the VIT system in the following ways. So we are going to, if we want to adjust the pmax, so what we are going to do, we are going to adjust the VIT systems. And how we are going to do adjust the VIT system, that we are going to supposed to see. The standard VIT program calculates the necessary VIT angle for increased part load using scavenged air pressure and engine speed as input signals. Therefore, a reduction of the fuel consumption is affected over the entire load range. The standard VIT program is individually adjusted during the shop trial of the engine. Okay, now a mode can be selected by an illuminated push button, VIT low NOx. The VIT angle is reduced and thereby the injection is retarded over a wide load range in order to reduce NOx emission. Okay, so this is what is done. Now adjustment of mechanical VIT. Now the pilot valve have been pre-adjusted to 0.5 to 5.5 bar control air pressure corresponding to 0.5 to 8 mm pressure in of the pin C. Okay, so you can see here, this is the pin C that is there. Okay, so by which we are adjusting it. Now to check a pilot valve already mounted on the engine, remove the inlet and outlet pipe connection at A and P. So we are going to remove this pipe, inlet and outlet connection A and this one P. Okay, and connect a pressure gauge at A. So after removing it, so this is not the actual system, this pressure gauge after what we have adjusted. Now and connect a pressure gauge at A and a pipe with working air pressure 7 bar, and we are going to connect a pipe of working at P, 7 bar working pressure on the pilot valve. So on the pilot valve we are going to connect a pipe of working pressure 7 bar, and on A we are going to connect what is known as the pressure gauge. Okay, check that the pressure on the pressure gauge and the pressing in of pin C in accordance with the curve. So this pressing of the sin, so what we are going to adjust the C that is given over here in the first point, that adjustment has to be in sync with this graph. Okay, so correspondingly how much you are going to adjust, and so how much it is going to pressure it is going to show on your pressure gauge. Any necessary adjustment is done by adjusting screw B. So any necessary turning adjustment is done by turning screw B. So if there is any fluctuation, if there is any distortion, and if it is not in sync with the curve that is there, so then we are going to adjust it through that this screw B, which is on the opposite side of the screw C. Okay, so that is done. Now fine adjustment of the pmax pressure in the breakpoint for all the cylinder is to be carried out by axial displacement of the bracket with the pilot valve. So it is done by the axial displacement of the bracket with the pilot valve. Now release the screw and nut which secure the bracket with the pilot valve to the larger bracket through the slotted holes. Now increase the pmax pressure by moving the pilot valve towards the lever. Decrease the pmax pressure by moving the pilot valve away from the lever. So this is, so how we are going to increase the pmax. pilot valve towards the lever. So we are going to adjust the pilot valve towards the lever, and we are going to decrease it pmax by moving the pilot valve away from the lever. So this way it is done. So I hope it is clear for you. Now when that we discussed about what is known as your mechanical VIT. Now when we speak about electronic VIT, the adjustment should be based on a set of indicator diagrams taken when the engine is running just above the brake point. Okay, on the panel in the engine room, control room, change the P offset value in accordance with the required increase or decrease in the Pmax pressure. One graduation mark on the P offset scale correspond to a change in Pmax of 1 bar. Okay, check the adjustment by taking a new set of indicator diagram while the engine is running just above the brake point. Now when we speak about FQS, now we have already seen what is known as your mechanical VIT. Now we have seen what is known as your electronic VIT. Now we are going to see this FQS. So this is also a very important aspect, and it is fuel quality setting. So how we are going to adjust the fuel qualities? Now the engine is, now here the objective is that the engine is equipped with a VIT plus FQS system, that is variable injection timing plus fuel quality setting, which permits an alteration of injection being during operation. So there is a if which allows you to have an alteration of injection during operation. Now the VIT FQS system produces a maximum firing pressure over a wide power range close to the value of the contracted maximum continuous rating, and thereby reduces the fuel consumption. It is also possible to tune the VIT plus FQS system to follow NOx emission. Okay, now the control of the VIT plus FQS is integrated in engine remote control. The manual FQS setting serves to take into account various fuel qualities. Fuel having a low ignition quality result in lower firing pressure for the same start of injection. So fuel which are having a lower quality, fuels having a lower ignition quality result in lower firing pressure for the same start of injection. That is, for compensation, the FQS angle has to be increased. So if that is the case, because of we have a fuel which is of lower ignition quality, so we'll have lower firing pressure, so we can adjust what is known as FQS angle has to be increased, fuel quality setting. Fuels with better ignition quality result in higher firing pressure for the same start of injection. That is, for compensation, the FQS angle has to be reduced. So the FQS angle has to be reduced for that. For this purpose, the FQS angle is defined as user parameter. So it is up to us. So now if you take an oil suppose in Gulf region in Iraq, and if you same oil you take in Venezuela, or if you the same oil you take in Singapore, so now the quality of this oil will be different. I mean, I will not comment on the quality, which one is better or which one is not. So but so some will have a better quality. If you take in Bombay High, so the oil will have different quality. So what you are going to do, this FQS, that is fuel quality setting, will come into picture. So with lower quality of fuel, so you are going to increase this FQS setting. So, and if higher quality, so we are going to decrease the FQS setting. -2° to +2°. So this is the range for the defined as user parameter in the engine control, and can be adjusted within the range of -2° to +2°. Okay, so that is done. Injection pump regulating linkage with electronic VIT and FQS. Now see, this is the linkage that we are looking. Independent from the utilized governor type, the regulating linkage transmits the movement of the governor output lever 1. Okay, so we have governor and governor output lever, that is there, it is 1. Okay, via the intermediate regulating shaft 4. So we have intermediate regulating shaft, that is known as 4, to the eccentric shaft 15. So there is a eccentric shaft which is 15, that is denoted over here. Okay, and then for the spill valve of the injection pump. So for the spill valve of the injection pump, the spill valve determines the end of injection and therefore the quality of injected fuel. So this spill valve determines your end of injection, and therefore the quality of fuel that is being injected. So that I hope it is clear for you. Now the adjustable rod too. This is the adjustable rod which we can adjust, ensure a rigid connection between the actuator and the regulating linkage. Actuator and regulating linkage. Okay, this is the thing. Now, in its normal operating mode, the VIT plus FQS system produces earlier injection in the partial power range and therefore raises the maximum firing pressure. With the manual adjustment FQS, the influence of fuel quality is compensated. Now, with the aid of pneumatic cylinder in the positioning unit 17 and via the connecting strap 18. Okay, so here you can see there that we have here it is 18. Okay, this portion, and then you have 17, this portion. Okay, connecting strap 18, the position of the suction valve and the spill valve regulating lever 9, spill valve regulating lever, that is 9. So this is the spill valve regulating lever, that is 9, that we were speaking about in previous slide also. And 14 which is simultaneously are simultaneously altered. They are simultaneously altered all at the same time. Okay, or maybe in one after the other. The moving out of the pneumatic cylinder gives higher VIT angle. So the moving out of the pneumatic cylinder, so when this pneumatic cylinder is moving out, so they give higher VIT angle, that is an earlier injection and therefore a higher maximum firing pressure. So in case of fuel quality is lower, so then we are going to do it. So this cam is going to moving out. This cylinder, pneumatic cylinder, is going to move out, so this will give your higher maximum firing pressure. So because we will have earlier injection. Okay, now see here this actuator and this 10 and that, see this is given, so this is the graph. So normal VIT system that is pertaining to this, when we have FQS setting, so you can see this graph. Okay, VIT plus FOS angle, this is there, and this is we have what is known as, if we draw a graph between engine power, that is percentage of engine power, and VIT plus FQS angle. Okay, so this is the pneumatic cylinder, so you can see this linkages, and then it is going to have, this is the spill valve that is there, and this is we have suction valve. Okay, and fuel to injection valve, so this is going to the injection valve. This is the actuator that we are speaking about, so 10, number 10, and then through these different linkages, and it is connected to this pneumatic cylinder, and based on this side, if it is moving towards the spill valve side, that is your advance, and if it is moving in opposite direction, which is not shown here, then it will be in a retard mode. When we speak about super VIT, now we have already discussed all those things. Now we are going to discuss about super VIT. The super VIT system is developed to fulfill the requirement of maintaining the MCR pmax under part load conditions. So see, when we are running all the engines right now, we must have sale except these new engines. So all those engine, when we are achieving this pmax condition is at the MCR, but what is not achieved, or what all the parameters of engine is not achieved, is in a under partial load condition, in order to save fuel. So we want to save the fuel, because if the engine is running on low load, then fuel consumption is pretty more as compared to engine running a higher load. This is achieved by a mechanism which automatically adjusts the commencement of fuel injection such that the MCR Pmax is kept constant as the engine load is reduced from 100% down to a certain pre-specified part load known as the breakpoint. So this is known as what is known as your breakpoint. Now how it is working? In the super VIT configuration employed on the larger LKSMC engine, the fuel pump plunger is not profiled, that is has no extra oblique cut, but instead the start of fuel injection timing is freely determined by altering the vertical O position O the pump barrel, whereby in the system the breakpoint is fully adjustable. So it is unlike your normal VIT system. The pump barrel is moved up and down relative to the plunger by means of a rack and pinion in combination with a double thread. The VIT rack setting itself is controlled by the regulating shaft position, that is according to the engine load. When running at the brake point, the Pmax cylinder will be at a low position, that is giving early injection, and the specified design Pmax MCR and Pmax V for the engine is in question, whereas in case of conventional VIT system the breakpoint is fixed. So this is the difference in when we speak about the breakpoint, fixed in relation to the pump index, that is the brake automatically occurs at the predetermined pump index. Now you see, this is the pump barrel, that is a this is the plunger, and we have double threaded injection timing regulating VIT. This mechanism is there, and position servo individual adjustment at the each fuel pump. So at each fuel pump we have this individual adjustment is there. Now this control air is going for operation. Now we have fuel quality regulator index. This is the fuel quality regulator index. Position sensor unit for collective adjustment is there. VIT rack position servos are collected by means of an air signal from the common position sensor valve, which is replaced by emergency stand. So this is the change that has occurred of emergency stand. Super VIT and the control mechanism, when we speak about, just have a look at the diagram. Now this beam A is connected to the regulating shaft fuel pump index control shaft via the regulating arm B jointed at C. So this is jointed at C, that is there. Now the VIT system is out of operation at low load. This is ordered to avoid frequent changes of pump lead VIT index during maneuvers. At zero load, the beam A is fully lifted. The position sensor D gives zero control pressure to the position servos at each fuel pump, such that a delayed injection timing is achieved compared to an engine without super VIT. So as compared to super, this is the D that we were speaking about. Okay, and this is the A. As the engine load is increased, the late injection mode continues until the beam A has made contact with the sensor pick up E, and the resulting pressure reaches 0.5 bar. At approx 85% MCR, the maximum combustion pressure reaches the specified design pmax for the engine. At this load, the beam A touches both supports F1 and F2, and the sensor pickup E is fully depressed as shown in the next slide. Okay. If the engine load is then increased above 85% MCR, the beam A will rotate around support F1, thereby reducing the depression of the pickup sensor E. Correspondingly, the control pressure from the sensor causes the VIT. Now see, now when we go back, if the engine load is increased 85% MCR, the beam A will rotate around support F1, thereby reducing the depression of the pickup sensor E. Correspondingly, the control pressure from the sensor causes the VIT rack position servos to retard the injection timing at a suitable rate, thereby keeping a constant maximum combustion pressure between approx 85% MCR and 100% MCR. Okay, super VIT operating principle. Operating mode of the position sensor valve, VIT regulating valve. This is on the low load condition, this is the breakpoint, and this is on the high load condition. So these are the three conditions that we are achieving, that is 3A, 3B and 3C. Okay. Now see, super VIT operates. This is the pmax variation schematic. So this is the breakpoint that we were speaking about. Now this VIT out of function. Okay, pressure 0.5 bar. So this variation when we speak about, now these are the parameter that is that variation takes place. So it is VIT index, control pressure. You can see here the breakpoint, how it will have an effect. This is the fuel index and this is the pmax line. It is between the load and then the variation, this graph. So In this, we have clearly seen how the operation of your VIT system, this variable injection timing, in which we have seen this conventional VIT system, wherein we have also seen this mechanical and electronic VIT. This what we have seen is what is super VIT. This is new concept that has come and how it is affecting all the parameters of your engine. We have also seen this fuel quality settings and how VIT, when having a control of this FQS system, is affecting your injection and then the compression pmax basically. So these things we have seen, and how you are getting different grade of the fuel, and how we are adjusting with VIT has to be this FQS setting has to be increased or decreased in what all cases. So these things we have seen clearly. You can go through the videos slowly so that it is self-explanatory for you. I am not going in depth because you all know it. It is only that I have collected materials from different sources. Try to combine it here so that it becomes easy for you to refer and understand at your own. Thank you so much.